Good morning, chat. My name is Penbu, the programming, puzzle gaming, and music making VTuber on Linux, and happy Pi Day. So yeah, happens to fall on a Saturday today, and Saturdays are somewhat odd times for me to stream, and usually only happens when there's a collab. No collab today. 5 to 9, welcome in. So yeah, apparently the last time we did Code Golf was in 2024, which I thought we did one in 2025, but I guess not. If you have an account, and it's, I think all you have to do is sign up sign in with your GitHub account. You can do the Pi Day challenge and get the Pi Day achievements. So if that's something that interests you, you can definitely follow along with us. We'll be doing this in JavaScript, probably a couple of other languages too, just because we can. I realized that I actually can golf in Lua. Last time we only did Bash and Bash and JavaScript. Can't remember if we did any other languages, but I think I know enough of Lua to be able to golf in Lua. Probably. We'll see. Maybe also PHP. We'll go through a bunch of these languages and see if we can or not. But I hope you're all doing well. I actually realized I did not get any pie today. I should maybe fix that. Or maybe not. I don't know. We'll see. It might be too late to go out by the time we're done. The stream may or may not be capped at 3 hours and 14 minutes. Depends on how we go. I just ordered a pizza. Did I have any? No, I didn't get any pizza. No. Oh, actually, wait. I might have pizza. I have a couple of pizza slices in the freezer. I can probably defrost one of those. Yeah, I might do that. It's not a whole pizza, but it's close enough. Also, I didn't realize he was debuting today, although it should have been obvious in hindsight. Alec MuVT had debuted earlier. A new math VTuber, go check him out. We seem to be getting a new influx of math VTubers recently. I think we've seen 2 or 3 pop up in the last half year or so. Sometime before was science VTubers, now getting math VTubers. So this is a welcome advancement. But yeah, today we are math but code. We're going to be doing this in JavaScript, at least to start. They've given us these hints. The OEIS, the Online Encyclopedia of Integer Sequences, probably not actually going to be useful for us, because we do have the exact answer here. We can just copy it. But 1,000 digits of pi, and you see here over on the side that the lowest scores are 60. You're not getting that by just pasting in the right. I have this in Vim mode. Forgot. You're not getting that by just pasting in all 1,000 digits of pi, because it's going to get you 1,002 plus whatever you need for printing. So that's no go. We have a Rosetta code, which means we're allowed to take these answers and then adapt them. They do have one for JavaScript. We're probably going to be looking at that. So there's a spigot algorithm, which is, from what I understand, is an iterative process that prints out the next digit of pi. Next digit or the nth digit of pi? I can't remember. But it doesn't matter. We don't have to understand how this works. We just need to know how to implement it. And we do have this. I don't know exactly how we're going to reduce this, but I'm sure there's a way. There's definitely a lot of spaces we can remove. And for example, the lets we can probably get rid of. Yeah, because we don't need to declare any variables. They just end with globals. make this a little bit bigger. But yeah, I'm guessing here the spigot algorithm is probably going to be our best bet, because it does seem relatively short, or at least shorter than the other ones that we're presented with here. So we're going to give that a shot. Okay, we're going to go ahead and copy that. Nope. Okay. So first we can get rid of all the spaces. I don't think there are any... We can get rid of all the lets. And then we can get rid of all the spaces, because I think there are no spaces that we would need to keep here. And then we can put all of these in one line. So this we can do... We can reduce to that. So the assignment operator, or the shorthand assignment operator. Right, I should probably explain what code golf is. So for those of you who haven't seen this before, the aim of code golf, as the name might suggest, is to write a program, but the program is as short as possible. So you will be resorting to language hacks to get this to be as short as possible. And we will see, we will absolutely see a bunch of those here. The question is, what will we end up doing? So this one, I think print is our print function. So there's that. And then we can change if I is equal to 3n, because we actually don't care about exact equality in this case. Actually, we don't even need that. We usually do a ternary here. And then 0, I guess. It doesn't, because it doesn't matter what happens afterwards. Okay. So this can be a +1. And actually we can, I think, so these n's here refer to big ints. Big ints. And the reason it's using a big int is so that it can represent as many digits as possible. Because if you're using the regular number, type, it eventually goes into scientific notation, you lose precision. We don't want to lose precision in this case. So we keep it as a big int, so we have arbitrary precision. So I think we can probably, if we go here, open up a node streaming. Yes. So if we open up a node REPL here, and we do 1n plus 1, not mix big int and other types, use explicit conversions. Okay, so that's, we can't save any characters through that, but we might be able to save. So if I is equal to 1n, and then we do I++, does that give us, sorry, plus I? Yeah, that should give us, that should allow us to increment and save a character. So instead of I plus equals 1n, we can save a bunch of these characters and just do I++. And actually, we can probably move this. We move this ++ over here, so that we do it as the last operation. And so the last time we see I, we can just do a ++ to increment it, and then it'll be the correct number in the next iteration. Yeah, no, I think that's correct. So, and then we have print here, print y. Can we do y? Can we just do that? 1n plus... Ooh, okay. I think we might be able to just do that. I don't know, we'll see. We might have to add a plus empty string to convert it to a string afterwards. But it's worth a shot. And then if I is equal to that, then you print this. We might be able to... Yeah, actually, we should be able to save some characters here, because if we do plus... and then we do that... But I think we will need to do this. Right, I forgot I don't have that plugin. So we can save some characters by doing that, because we save on the print. Compound assignment on line 6. Probably could, yeah. Yeah, because then we can rearrange this. So this says 10 Q times 10n. Which then means that we can compound assignment, change this to a compound assignment, so we have that. I wonder if we can actually... No, we probably couldn't, or maybe. We might have to do some math here and figure out where we can squish things together. We can actually remove all the semicolons, actually, except for the ones in the 4. Because in this case, JavaScript considers, at least for these statements, the semicolons and new lines to be the same because of automatic semicolon insertion. So we can have our code looking a little bit nicer without having to make everything in one line and still work the same. Okay. 2n times I++ can be I plus I++. Yes, yes it can. Because that saves us one character, or yeah, something like that, one character. Yeah, okay. Can we do I to the 2? Is that on a thing in JavaScript? I swear there was a exponent operator. Oh, it's the asterisk, is that right? Okay. Can we do that? Can we do 2n? Yeah. I don't know if that's gonna help though. Maybe not. So, hold on, wait a minute. So if we do, so this, we do let's open a new one. Open Vim here. So our current solution is this. And if we do instead I to the I, or I to the 2, well, I times I guess, plus I, that makes sense. Okay, actually, maybe it makes sense to expand it first and then try to reduce it. So this I times I times plus I times I. Oh, that's actually, no, that's not how multiplication. Oh, actually, no, it can work. You do this. So I times I plus I times I plus, or minus I, or minus I. And if you reduce this, that actually ends up bigger. So that's probably not going to work. No, but this is 2i. So if this ends up being 2 times I times I, times I times I, and then we have plus plus. Assuming I have my math right, that actually ends up shorter. Right? Because this was originally, this is really originally 2n times I. And then you can distribute the I into this. Right? So I think that's how math works. You can distribute the I into it to make it I squared. 2 times I squared minus I. Yeah, this should be okay. We're gonna go ahead and copy that. And then we actually don't need the new line there because we can just start right away. And we can do this 5n feels like we should be able to move that out, but actually no, maybe not. Do we use, oh actually no, we use 5n in a few places. We actually can save a couple of characters by putting it into a variable. F equals 5n. And then we can change this with F. Because that saves us, I think that saves us one character? 2 characters? 1 character over the span of this. And then we use 10 twice. We use 3n 1, 2, 3, 4 times. We might actually be able to reduce this one. So 3n, we're gonna go ahead and copy that. Let's see if we can reduce that. Okay. So if we distribute this, we end up with can we just reduce this to, so this is plus 3n, this becomes 9n, right? We still need the brackets here, times 3n times I plus 2n. Now if we distribute this into here, so we do u equals 3 times 9 is 27. 27n times I squared. I times I plus 9n times 2n, so that's 18n times I, and then plus 9i. That's another 27i, and then plus 6n, so that's actually shorter. Can we move anything else out? And we can probably take this 27n. Actually, maybe not, because if we don't use 27n more than 3 times or more than twice, then it's not worth it. It's only when we use it 3 times or higher or more than where it becomes worth it. So I think this is probably okay. Okay, so we'll do that. U equals that. And y is equal to all of this. 27n times I plus I. That work? Because if you do... Hold on. Oh yeah, no, I guess, yeah, you can factor out the 27 from the first two terms. So if you do 27n times I times I plus I. So factoring out the 27 from these two terms, you end up with this, and then plus 6n. That saves us 2 characters. So yes, that is absolutely something we can do. Good catch. This has to be plus 6n. Too bad we can't factor out all these n's. And then actually this u, do we need this u anywhere else? We do. We need it for t here. We actually do need to save this, and we can't just inline it. So in the original, we have u and y be independent per loop. So y is something we can possibly inline. Oh no, we can't, because we use it here and we use it here. Oh, sorry, we define it here, we use it here, and then we use it here, which means we can't easily. We can't easily just inline it. So if q equals 1n, r is equal to 180n, t is 60n. Can we define? I don't think if we define t first, can we do t times 2? Does that actually save us? That actually saves us characters. T times 3. So we define t first, then we can do that. Oh, except, actually we need to make it 3n. So does that actually save us any characters? No, because then we need 180n. It's the same thing. But this is trick to save us any number or any characters anywhere else. I mean, it doesn't hurt to do this, I think, which is fine. I is q plus q, but that's actually more characters than just 2n, so that's fine. F is equal to 5n, which we use here. And we have 27n there. If we have 4, actually no, this saves us characters. If we do, or does it? If we do, what do we say 27 is? What is 27? It's actually over. Give me a base. What is it? 26 plus 10. 26 plus 9. Base 35. No, I need it the other way. 27. I could just count this out. We can call it R. We already have R. We can call it capital R. So let's say the capital letters are number stand in. Just so we don't get confused here. I'm missing one. And then R is equal to 27n. We have R here, so that saves us 1. And I think that actually saves us another 1. Yeah, that saves us a few characters. 12n is t divided by f, which doesn't actually save us any characters. 10 I think can save us some, so that's going to be A equals 10n. $169 versus 173. Is there anything else? 6n only appears once. That's fine. Otherwise, would be. Where do we get T from? T. Okay, no, doesn't actually work. Okay, so we're at 169 characters, which is nowhere close to 60. If we do I is equal to so 3n shows up here, which means we can actually do. Let's move all these ones up to the front, so we have all our numbers first. If we do t equals 3n, and then we can do t here, and then we can do t here. If I minus t, we can save a character there, because if it's exactly... No, this doesn't work. Actually, yes, this will work. So if I minus t is 0, then we print, otherwise we don't print. So if it's anything that's not 0, do we need 2 print calls? You're right, we do not. So we can save the print there because we attached it directly onto here, so that's fine. Now we're at 164 characters. In before the solutions other people went with is not the spigot algorithm. Okay, can we reduce this any further? It doesn't look like it. This here feels like we maybe should be able to. I also don't know if this works. I don't think we haven't actually tested anything yet. So looking at these numbers, can we save anything else? T times t. Right, because this used to be 180. We may have actually increased our character count here, because we don't. If we only needed a 3n once, because we introduced a copy of 3n. If we only needed it here, then we can actually get rid of this and put this back to 180. Oh, no, wait, we do save characters. Because if this would have been one... No, wait, no, we don't. We save one on the equals sign. That's 160. Because if we only need the 3n there, then we don't need to. And then we have a 2n here and a 2n here. If we do t equals 2n, no, I don't think we save anything here. T equals 2n there, and we have oh, wait a minute, hold on. T there, and we actually need a T here, because this needs to be 2n times I, so we actually do save characters there. 163. Which apparently we don't save any characters, because... reasons? Okay. So then does that mean that if all of our F's here, if we make that 5n, 1, 2, 3, then we should be saving characters here. So if this is 5n, this is 5n, this is 5n, and we remove this, 159. Wait, hold on, so we actually do save characters from this. /F/T. Where are you looking? Because T is one of the ones that we actually need as a variable that survives the loop. So the T here actually has significance. Line 2 denominator doesn't need parentheses. yes, because we can just turn that into a slash. Yes, you're right. So the 27N, does this actually save as characters? This one might. This one might, because this is 3 characters instead of just the 2 characters that we had before. Maybe no numerator if you factor out the 5. So if we factor out the 5... Okay, so we write this... Oh, but that means factoring it out of here. So if we factor out the 5... Because 5 doesn't fit into 12, so I don't think that really works. 5 doesn't fit into 27 either. So factors of 27, you have 3 and 9. Or I guess prime factors would be all 3s. Because 3 cubed. Which means you won't be able to fit a 5 in there. For 12, you have 4 and 3, which means 4, 2, 2, which means there's no 5. And then Q is a running variable. So I don't know if we're going to be able to... Hold on. If we split this out, so we get rid of the 5 here. Then we can have this as slash T... Let's try this out. So if we move that down there, and we break this out, so then that means that we get slash 5n slash t plus 5n slash 5n slash t. And if you remove this, that means you get rid of this. You get rid of this, and then you end up with r divided by t here, and then you have just put in the original line. It's already shorter, so it might actually be worth it. But if you then put this in parentheses. Get rid of the slash t there, put this in parentheses. It's the same thing. So yeah, we can go with this one. Let's go with this one. Okay. So now 154 characters. Can we get this down anymore? What about this one? So we had 5n. I think we said that it wouldn't do anything. It wouldn't help to put that into a variable. But I guess unless we have 4 instances of 5n, it's not going to help us. A is 10, and so yeah, anything that has 1, 2, 3. I'm not sure this actually, does this help us? If we get rid of this, 152. Oh, it does. Saved a few characters there, unless I missed an A. I didn't. So then, okay. For argument's sake here, then if we put back the 27 ends here, because maybe it'll actually help. What was it before? Was that 152? There's only... Okay, so we can get rid of that too. Now we're at 150. How are you all getting 60s? Can you... Can we actually inline anything? So we have a... If we have 2... Actually, yes. Yes, I think we can. Because we might be able to... So if we inline this, we have 1, 2, 3 characters, whereas if we inline it, we only need 2 characters. We take this, put that, and we actually save on probably the new line as well. And then we can, wait, no, that's not right. Because we still need the y equals. So did we save anything with that? Still 150, so I don't think we saved anything there. Because we still need, so the inlining would mean +2 for the parentheses, and then +2 for the assignment, whereas this is +2 for the assignment and then +1 for the new line and +1 for the variable. So it doesn't actually save us anything, which means inlining the U probably won't save us anything either. We can move these into there. That saves us character. We can move... Oh, man. Oh, man. Alright. How much of this is going to be worth it? We can save on the... Oh, I don't like this. We can save on the braces. Unfortunately, this does mean that we're going to have to put everything in one line. But we can put all of that into the third part of the for loop. So now we have no body in the for. Well, actually, we do need a body. Will this run without one, actually? Can we do that? Is that something we can do? Or, console.log I, or 0. Wait, hold on. Can't do that. Stop doing that. We need to kill that. Send, give me this, send settings, plugins, more, edits, file, view, it's in here somewhere, send signal. Oh, we're good. We ran out of memory or something. If we do say for I equals 0, I is less than 3, I plus plus, it'll wait for a thing. Okay. Which means we actually do need the semicolon there, unfortunately. That brings us down to 148 characters by getting rid of the braces. Makes it a lot harder to read, but still nowhere close to 60. Okay, we're gonna go ahead and copy this. Put it in here. And we'll make every semicolon or every comma a new line. Just to make it easier for us to read. And then let's figure things out. So can we combine anything here? So we have Q. Where's Q come from? Q comes from this. Q equals 1n, and then Q ends up being overwritten afterwards. Q gets overwritten afterwards. T also gets overwritten afterwards. T equals U. Can we change up the order of these so that Now we can possibly inline things. But also, wait a minute, compound assignments. Compound assignments are, they're not expressions, are they? Let's say the addition assignment, perform is an operator, which means you can put them in expressions. So if we do a is equal to 1, and then we do b is equal to a, say 2 plus a plus equals 1. So we expect to see a have 2 and then b have 4. Okay, so you can't put them in expressions. But I don't think, I think as we discovered before, that doesn't actually save us anything, right? Because say if we change this one to a, well, we can't because we need the old value t. So that's not actually going to work. So y is equal to this, which we need for this and this, and then we have u is equal to this, or this, which we need here and then here. So we can't reduce that. I don't think we can reduce that any further. Q is equal to 1n, which then has this, and then we have t. Starting off as that, we have t here. R is equal to 180, n, which is t times 2n, so t times I. Or no, it's t times 3n. No, we don't have a 3n anywhere. Because if we did that, and which I think we tried, if we tried doing, if we put it into a variable, say t equals 3n, then we use a couple more characters than if we just inlined everything, so I don't think that works. Are we all getting 60? Hold on, let's see if there's anything else here that's because this is also a spigot algorithm, I think. Why would you do it this way? Oh, because it's using a bigot library, I see. But yeah, this one's also a spigot algorithm. Simple approximation returns an approximation of pi. Is this good enough? Wait a minute, hold on. Because we only need it to 1,000 decimal places. One moment. I don't know what's in the air today. I've been feeling like I need to sneeze every so often. Okay, hold on. Wait a minute. When does this terminate? I don't think this terminates. We only need this for 1,000 iterations. And I don't think this terminates. I am going to put this in a node and see what happens. Yeah, that doesn't actually terminate. Hold on. (1000n minus I). We do that. So it ends at 2:01, and our thing should also end at a little bit more than that. Three more than that. $989. Yeah, okay. But what about the approximation? I don't expect the approximation to give us anything good though. That's not good enough. If we're gonna do this, because this is just a regular number, right? If we're gonna do this, then we may as well just turn this into. May as well just use math.py, which, by the way, I already checked, and this doesn't give us enough precision to print out 1,000 digits, so kind of pointless. But what if we turn these into big nums? And we can't because it uses division. We can't do that. Yeah, no, that's not gonna work. Okay, so I guess we keep iterating on the spigot algorithm. Which honestly, I don't see a way for us to reduce, unless. Because I see here I times I plus I, when you have I times I plus plus. Oh, this is now wrong, actually. Because now that we have a another set for I, IME has been activated. We actually need this over here instead. Minus I plus plus there. So we have I times I here. That's 3, and then I times I here. That's also another 3. And we have plus I. We have minus I over here. I don't think we save anything if we put I times I into a variable. Because we do I times I and I times I, whereas if we do say I is equal to I times I, and then we have two references, that actually increases our count. So that's not good. I don't know, 148. Did I miss one? Is this not resolved? Am I missing one? Oh, that's one too many. That should be that. Okay, so 147. How are you all getting 60? I thought this was going to be easy. Also, how many hours do we have left until we can't solve this anymore? 2 hours. 2 hours from now. Okay, I think I might. Yeah, that's about right. It's UTC. I think is at 7 nowadays, 7 p.m. because of daylight savings time. Yeah, 7? Okay, so right now I'm UTC minus 4. Midnight minus 4. When does this roll over? I don't have my math wrong. Is it actually at 8? Whatever, we have 2 hours. How are you all getting 60? Because we are a little over half or double their character count. What other methods do we have here? Because it's not the spigot algorithm. We can't do this one because this is to infinity, and we don't have infinite. We don't have infinite iterations, or maybe we do. Maybe we do. Retain and use all intermediate digits until the final result is produced, which we don't really. I mean, it doesn't matter if we do that though. Modern pi calculators do not use iterative algorithms exclusively. New infinite series were discovered in the 1980s, 1990s, are as fast as iterative algorithms, yet simpler, less memory intensive. The fast iterative algorithms are anticipated in 1914. Based on modular equations is this. So if we can take this and then reverse it, there's a bunch of magic numbers, and this looks like it could potentially go to oh, but wait a minute, we don't have big decimal. This would have been so much easier if JavaScript had big decimal, but it doesn't. It only has big int. Integer relation algorithm, where q is equal to e to the pi. I think we're probably stuck with the spigot algorithm, because if we don't have big decimal, then the only way for us to have enough precision is to print them one by one. Actually, wait a minute. Do we even need the big nums? Why do we need big nums? Is it because it's probably because they end up really, really large. Yeah, because we do have a bunch of multiplication, so I assume these probably get... yeah, so t, for example, only multiplies. And the result of this will just end up growing. So yeah, I think they end up as big nums because they end up growing large enough that they would end up in scientific notation if we were just using regular numbers. So I think we do have to keep these as big nums, but not that... Sorry, big ints. Not that it would change a whole lot, because that's what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 ends. I'm seeing a lot of 2 ends here, actually. We can probably... t equals 2n times t and times t here. Did we try this already? We're at 147. I feel like we might have tried this already. 150. We gained 2 characters. This is 2n times 6n. But we don't have a 6n. That doesn't actually give us anything. We have a 6n here. But bringing that out actually just adds more characters. We can't do that. I don't know. I think it's probably best if we just submit for now. And then see if we can improve afterwards, because at least we have a submission of some sort. Right, this actually will not... Okay, seems like we need to put it all in one string. Okay. Well, that's unfortunate. We're gonna always equal to empty string. We can actually do that. We can't do that. We can't do that because this actually calculates. This actually calculates the initial 3, so we can't actually. Wait a minute, hold on. Can we bake in the first set of terms? Because if we only go for, we can remove the I minus 3 if we calculate the first set of terms. Because if we start at I equals 3, I equals 4, I equals 4. Because we know the first term is going to be 3 points. So we go from I equals 4, then we can bake in the 3 points here, and then get rid of this. Get rid of this. This whole ternary here. That actually saves us a ton of characters. So then the question is, what does that end up being? I don't want to calculate that. Let's bring out a spreadsheet. I don't know what that is. I'm not sure I care. I don't think I do any serious spreadsheet work here anyway. Okay, so we have Q. Then we have R. Then T. Then I. So if we have that as 180, 60, and 2. And then we have Y, and then U. And this is going to be this. And we just adapt that. It's going to be this times 27 times I. Oh, we started I equals 2. Okay, so we actually only need the we only need one more iteration then. Two iterations times R divided by 5 times T. It's gonna be this. I don't know what I did wrong, but yes, I think. Oh, I probably missed the V1 times. Did I miss a? No, I missed a. Okay, I missed one here. It needs to be that. 3.14. That seems suspicious. And then U is this whole thing. Get rid of this, get rid of this, get rid of that, get rid of that, get rid of that, and I is this, and then I is this. Then R is equal to this whole thing. So this is going to be the next one. That's going to be 10 times U is this, and Q is equal to this. 5I times 2 plus R, which is this. Y times this, and then T is this. I don't know what these numbers are, but if this is what the formula needs, I guess that's what we're working with. 10 times Q, which is the previous Q, and then you have I, which is this one, and times 2 times I again, and then minus 1, whatever that means. And then it's going to be t times u. It's going to be that. And then I is equal to I plus 1. I copy that here, copy that here. Again, whatever that means. And we should be able to just copy everything over like this. And then these are our values, which are not looking great. Wait a minute, hold on. Because they're big ints, they get truncated? Is that how that works? I need to floor these? I think I need to floor these. Because they're big ints and they don't do decimals. This makes more sense. Three, 1, 4, 1, 5, 9, 2, and yes, it does continue. Okay. So then the question is, does this actually save us anything? Because if these are going to be this large, what are we doing? Because if it's going to be this large here, so if we're taking these values, this is already more than what we would save from the ternary. So this isn't worth it. Unless we can multiply two numbers. Factor. Okay, so we have a bunch of factors here. I don't know if these will help. Because I'm seeing numbers that, if you multiply them, are probably going to end up being at least as large as this, if not larger, when you write it out in code. Because you have a 3-digit and a 2-digit number, which it looks like it's going to be what happens here. Then that's already 5, and then you add +1 for the times operator. So that's not worth it. Unless you find a common factor between these two, and then you happen to put that in a variable and share them, and there's something. But even then, I don't think that's worth it. That's too bad. So this is actually going to be an empty string. This is going to be O plus equals this. And then we have print O plus equals that. Do we actually need... do we need the parentheses? Do we look at operator precedence? I think we do, because the assignment operator, I think... Actually, maybe not. Where is this? So we have the... We need the conditional operator to be above the assignment operator, and that doesn't look like that's the case. Yeah, so we do need it. We do need it because if we don't have it, then the assignment operator will become part of the condition for the ternary, and that's not what we want. We want the ternary to be inside. Oh, but wait a minute, we don't care. because the ternary is already inside a set of parentheses. So actually we can get rid of this. We can get rid of one set. Because it's O plus Y plus this stuff. And then plus binds closer than the addition assignment. We actually can get rid of one set of parentheses. Then we have the print here, which has that. And then we can move this into here. Doesn't really change anything. Yeah, that doesn't really change anything, but it's still good to have. This needs to be an empty string, because otherwise we end up adding stuff onto the string and we don't want that. I think. (3n). I think we went over this, so we can't do anything with 3n. Okay, so I'm gonna go ahead and run that, so at least we have some sort of submission. Failed for exceeding the 5-second timeout. That's right. Oh, we only want to print once. Hold up. That's right. So we don't want to do that. We want to print just once. We actually need to have this print outside. Print O. And then we have I minus 103n. Ugh. I don't think there's a way around that. Now we're back on 163 characters, but at least we have the achievement. Okay. Are there any obvious ways we can remove? How am I the only one with 163 characters? That means there's some optimizations that we haven't done. If we're putting everything into a string, that means we can insert the dot afterwards. Right? Because we don't need to check it every time, because we know we have a fixed position for this dot. We're not printing it out one by one. We're going to be collecting everything into a string that we can insert the dot afterwards. So then the question is, can we do that in a way that reduces however many characters this is? Possibly. So the important part is this part. This is the part that we want to get rid of. And we have, if we make O to be an array, we can't do that because arrays are expensive. Can we substring easily? I don't think a substring is going to be... We can do splice. O.splice. Oh, actually, hold on. Or not splice, slice. String.prototype.slice gets us the section of the string. Because we can hardcode 3.14. Or like we can hardcode three dots. And so if we do from the first character onwards, so slice 1, 3 plus, or 3 dot plus, that's actually more though. But compared to, hold on, I think we need more information. Because actually, no, we save the plus there. And we have print O. No, this doesn't save us any characters. Kind of unfortunate. And unfortunately, JavaScript doesn't have any shorthand for, it doesn't have a shorthand for slicing or substringing. Because Python, I think you can do, just do the range in square brackets. Would be nice. And there may be a TC39 proposal for that, but it's not out yet. Okay, we can do template strings, which I think are going to be even worse, but it's worth trying. Yeah, no. We can't do that. Have you ever wished everything was 11.111% slower or faster? Hassel, welcome in. Python's array strings like so much fun. Yeah, it would be nice. I'm not sure what this 11.111% is a reference to. It's a very specific number. This is unfortunate, and we can't do that. It would be nice. Can we actually just chop off... Can we just chop off the first bits? Maybe a splice or something? No, that's gonna be worse. We can't insert... String.prototype.splice... It's not a thing. Substring? No. Locale compare. No, it's not going to do anything. Replace. You know, maybe. I think that's going to be way more. But it's worth a shot. Yeah. Yeah, that's going to be more. This is a reference to a dimensional analysis mistake I discovered in my modding project last night. Ah, I see. No, I mean... I don't see how the specific 11% factors in. It's probably a conversion factor of some sort, maybe. But I can see how dimensional analysis could have led to that. You have like t to the power of 1/9 dimensions off or something. Yeah, I guess it is 1/9, isn't it? Okay, so where's the obvious one character that we can remove? Because the actually, wait, no, hold on. It's not just one character. It's we need to shave off. What is this? 5 characters. How do we shave off 5 characters? Let's start with that. Because we already shaved off 1 character compared to the next highest. So the one above us is 5 characters off. In which all floating point-based math ran too fast by that much. I went unnoticed because of 30's proximity to square root of 1000. Square root of 1000. Square root 31.62. Okay. So then how did you discover that it went that it was off? If it went unnoticed. I was computing DT times 1000 over 30 in place where it should have been DT times 30. Ah, okay. Yeah, that's would certainly do it. Can we shave off? Because this feels like it shouldn't. I don't know. The 1003 seems kind of big here. Because that's what, 10 plus 3? That doesn't actually give us anything. 10 times 10 plus 3. Divided by 2, so that's 500 times. I don't think 1000 divides into 100, or 180 divides into 1000, does it? 1180. Yeah, no shot. But 180 times 5. Do we have a 5? So R times 5n. No, that actually ends up with more, so we can't do that. Passing, words out a few weeks ago, lengthy write-up in Clonk's Discord a few days ago. I actually checked my code 3 to 14 hours. Okay. Yeah, sometimes it takes a while to get there. Is 5 character? I don't actually see a way we can get 5 characters off this. Because we, oh, hold on. Can we get rid of any parentheses? That might be the easiest part. But I don't think so, because we need this one, because that has a... Do we? Can we save 4 characters? Are we able to extract this out somewhere? I don't think so. Because we saved the 2 characters, but we traded for double of this, so that doesn't actually save us anything. Does the n and the y factor out and get cancelled by the 5n? I might be missing something. Looks like n times 27 times I. So no, the n suffix here refers to a type. So instead of this being a regular 27 number, it's a 27 big int. And because the numbers get so large, we're stuck with big ints. So there's no getting around those ends, I think. Easier if I edit out an interrupting sticker. I can send that to Discord. Yeah, programming. I don't know. Yeah, okay. Is there a way we can get around not having O? It doesn't feel like it. Oh, actually, we can take this last one out. We can save a character. We can save a character. But just one. We can put this out as the last one. I know this doesn't work. Because all this stuff happens beforehand. We can take out... Where is this? We can still save a character. We just need to extract the right one. It's this one. Oh, this is kind of... I mean, it's code golf. Of course, it's going to be kind of cursed. We save a character. That's 162. So for anyone confused, we have here... I'm going to move this over into a thing here. Make it easier to read. So basically our for loop looks like this. So this is our initialization. This is our condition. And then we have this as our loop body. And then all of this is our post actions. So this is the stuff that happens after the body of the loop. Which means by taking the first bit from here and putting it down into the loop body, we save a character because then we don't need the comma. So this runs first, and then all this stuff runs. It's kind of confusing, but this is what you have to do when you golf. So we save a character, but can we save any more? So now we need to get rid of 4 characters. We got rid of 1. Can we get rid of 4 more? Or we can move on to a different language. That works too. Alright, I should probably paste this again and maybe pin it. Pin. If anyone of you want to try this for yourself, I think you have about another hour to get the badge. Just gotta submit something. Alright, the solution is right here. It's not very well golfed, but it is a solution. Oh, we should come back to this. Shouldn't we come back to this? Bash should be easier, right? How large can bash numbers be? Are they arbitrarily large? Bash numbers size limit. Original file didn't have this in it. No, is it independent from the bit size of your OS? Depends on a simple declaration deep inside the bash sources. There's unfortunately going to be an int64, which is not going to be large enough for what we need. Haha. Actually, hold on. Bash, these are all integers. Bash doesn't do decimals. And yeah, they're not floating points. So how large is a 64-bit integer? My psychology gives me less FOMO if I avoid the site altogether. Fair enough. But if we look at this is plenty large. And this is going to get even larger. I don't think this fits into a 64-bit integer. Signed int max. Student is 63 minus 1. I should expect that. How large can we get? How much can we get before we exceed the signed 64 bits? This. Which is not very far. We need 1,000 digits. This is not going to work. Now, they do have a bash thing here. I don't like the look of that. How do you even deal with that? Oh, I see. This implements big num using arrays. Yuck. I don't want to do that. I think 162 might be the best we have so far for this one. I don't know how they all got 60. I wonder what rules they use for measuring ASM. Good question. I think it might still be characters, because they have assembly here. It's by bytes. Ah, okay, yeah, so it's by bytes. So I guess it's by instruction bytes. Because I don't... Yeah, it looks like it's probably by instruction modes. I think this is x86 assembly. Could be wrong about that. It's in the about somewhere. But it's going to be whatever output it ends up being. Oh yeah, for those of you who don't care about the badge, you can do this without an account too. You just won't save your progress or anything. There's also Lua. The lowest solution is 120 characters, 120 bytes. I don't think we're going to get anywhere close to that. Most people are at 1009. Which seems like it's probably more attainable. Okay, so we're going to take the... wait a minute. Translation of Pascal. Okay, so that's the spigot algorithm still. I don't, as much as we've been going through learning Pascal, and I realize it's been a while since the last one, so everyone's probably forgotten, including probably me. I don't know it well enough to be able to golf it, so I don't think we're going to attempt that. Lua, maybe. If I understand how any of this works, though. But we can try. We can take this first. I think well, the problem is it doesn't print it out in the format that we want it to. Which means we're going to n equals 1000. Where do we get this from? For for j equals 1 to n, does n actually show up anywhere else? No. So that's might be pretty easy to reduce down. So A, I think this is going to be the table. So Lua has table instead of arrays, but they're more or less the same thing. I think the table here is going to be where the answer is going to be stored. So instead of n there, we have n equals 1000 here. We'll have m equals math, because we use math in a bunch of places. And then we'll have capital M be that, actually. Have math be capital M. We'll have F be mod F. M dot mod F, and then G equals M dot F mod. Do we need to do that? Yeah, we have F mods a couple of times here. That might actually save us a few things. Which means, do we save anything? Yeah, no, we saved some characters from doing that. Taking out the math here. Prints. Okay, so Lua gets us print here. So all these io.write we can change to print. This doesn't make sense. Okay, no, this prints digit by digit, which is not what we want. M.mod F ends up being F. And then M.f mod equals G. Why did I do it this way? I have no idea what those characters mean, or what these functions do. But it's a pretty simple transformation. Okay, so we can more or less get rid of all the spaces here. More or less. Because in Lua, most spaces don't actually matter. Including possibly this one. But I actually don't have a way to check here unless I maybe pull up EG sub, but I don't want to do that. We do need this. I'm going to assume we need this. Actually, we can just put it into the text box and see. For 1 to 1000, do this. For I equals length 1 to -1, do this, all that. I have no idea what this code is actually doing. If Q is equal 9, then 9 equals 9 plus 1, and unfortunately, wait a minute, Lua doesn't have any shorthands for this. I don't think we have a plus plus, and I don't think we have the assignments, the addition assignment, so we're kind of stuck with that one. But we can shorten that variable name. So we can make pre-digit be P or capital P. Or K equals 1 to N, do that. Or K equals 1 to N, do that. Then we got, should be everything. I think we might actually be able to save the space there. I'm going to save a space here, save another space there. We're going to save a space there, save a space there. And another space there. I think those are all the spaces we can save. However, this doesn't print what we want. Because we need this in, where is A? Where does A end up going? Okay, I actually don't know what A is doing. So we'll have O as our output again. I equals length, so going backwards from length to 1. What? If Q equals 10. I don't understand what this code is doing. So with minor editing changes is published by this minor improvement of speed of about 2 n equals 10,000 runtime 4 seconds by calculating only necessary digits up to n, which is what we want. But how does that work? Plus 16 for security digits, about 5 decimals. You work backwards. X mod start with 2. First pre-digit is a 0. We actually want to get rid of this, and then we want to add write ln pre-digit. Yeah, write the last one. So instead of printing, we can add to the table. What's the easiest way to do that? Lua table append. Is there a syntax that we can make use of here? Other than using table.insert, because I don't want to do that. or the corresponding object-oriented version, which is almost certainly shorter. Is it? It might not be. It might actually be shorter. No, it has to be. Probably, because we save on the table keyword. Can we just plus? I don't think we can just plus the table. But no, we do have I. We don't have I as a counter. We don't have I as a counter. Oh wait, len, that can be L. We do kind of have I as a counter. Carmelos, welcome in. What is this? This is, we're working on Code Golf, trying to get, trying to print out 1,000 digits of pi in as few characters as possible. Earlier we did a JavaScript version, looks like this. We got to 162 characters, and the top answer is 60, or uses only 60 characters, so we're way off. And we haven't been able to figure out how to get to 158 knockoff 4 characters. But yeah, we're moving on to a different language at the moment, so we'll see if we can get any better results here. Is that NVim? No, it is not NeoVim. It is just regular Vim. I haven't found the need to switch to NeoVim as much as people say it's worth it. Regular Vim suits me just fine. Yeah. So anyway, we're working on Lua. And we got the code from Rosetta code, and looking at other solutions looking at other non-golf solutions is allowed, presumably, because they did link it here. I don't know how this works. Presumably it's a spigot algorithm, and you're working backwards somehow, but yeah, no, I don't know how this works. So we're just trying to hold on. We can probably get rid of all these 10s. So we do t equals 10. We change that all to t's. Should save no, not that one. Should save a few here. And the only multi-digit number we have is this, which can be t times... Does Lua have exponentiation? I don't think it does. Oh. Ooh. Wait a minute. Yeah. Yes, it does. According to the AI summary. I have a Lua REPL. Hold on, what am I doing? Three to 3, 27. Yes, okay. So actually, we might be able to save. So we do t to the 3, then we should have that. I'm gonna save on one character. And then what? So the goal here, I think, is we're going to try to reduce all of these. So the prints, they can all go. They all have to be replaced with something that references O, and then we have this. So we have length minus I. I think length minus I plus 1, possibly. Yeah, it has to be +1 because this is Lua. Because your first one is going to be... Oh, wait a minute, hold on. We don't actually want this 0. So, for those of you who are not familiar with Lua, Lua tables start at index 1 instead of index 0 like most other languages. So you often end up having to do a +1 in various places. However, we might be able to use that to our advantage because... where is the Lua example? Lua, this actually prints out a 0 at the start, and we don't want that 0. So if we put it at index 0, so if we have a table A, and we put at A 3, say for example, and then we print A, or then A at 1 is equal to 4, and then we do what is it, io.write? Actually, I don't remember how to to-string a table. .join table.join. Table.string or table. The string dot 539. Do you remember how to? I should know how to do this. Change a table into a string, or rather, more directly, print a table. With yesterday's finding, I should take another stab at running the vanilla and modded game side by side to see how well they synchronize. It'd be probably worth it. No built-in thing. Okay. Swear there have been times. Oh, hold on. I have done it before where I've turned a table into a string. So there's got to be a way to do that somehow. Lua table to string. Lua prints table. Does this exist? Does that actually exist? Table.concat. Concat? Thought that would have done it based on tables. That's not what we want. What? Table.toString sounds like an extension from a particular Lua embedding. Yeah, that's probably true. What a shot. Yeah, there is no toString. Hold on. I don't understand how we got 4 file here. Is it because we got the 0? Probably because we had the 0. So if we put b at 1 equals, say, 5, table.concat b. Oh, okay, hold on. So it's just a problem of the io.write thing that we were doing then. And of course this we would have to do that. No? Is this a LuaJIT function? Or a LuaJIT method? I swear you were able to do that. Is that a LuaJIT extension? I don't think so. Because B is a table. Attempt to call a nil value of method concat. Okay. Maybe I don't understand Lua well enough. But in any case, these prints... Oh no. Oh no. Do we actually have to have a counter? I think we might have to have a counter. For J... okay, we can't rely on that. for I equals 1. Capital I. The follow text isn't part of the value. Yeah. So O at I. Oh no, this doesn't work. No. Oh, it's the return value of io.I. See. That would make sense. Only concern the REPL, yeah. I don't think this works. Because then I'm going to need to do something here. It's like do I equals I plus 1. I'm going to have to do that every time here. O I is equal to 0. And the end. And then you have else. Do I just write a new function for this? But that's gonna take up way more characters than I need it to. Every time we assign, we have to do an I equals I plus 1. I feel like that's taking up more characters than print. Oh. Yes, actually, that is useful. We're going to switch to that. So instead of, it's going to be slow, or probably potentially slower, but we don't care about runtime. So the length of O plus 1. Because Lua tables are 1 based. Which means if the length of O is 0, then you insert into the first slot here. But actually, we do want just the length of O because the first character we get is going to be a 0. We don't want the 0, so we can put that into slot 0, and then have the 3 go into 1. That should be okay. Then we can do that. And then everywhere where we have the prints, should be able to do that. And then you table.concat we're gonna be missing the dots. Well, let's get this working first. So to start, does this at all work? And we're at 361 characters, which is less than what everyone else has, so that's good. This is going to be... It's going to fail because... Attempt to perform an arithmetic value... arithmetic on nil value global n. Where do we get n from? N is there. Where did I remove that from? Oh, right, because I had this. So n was actually... So we have 3 characters here. There are 3 characters here. So we have 2 counts of that versus n equals t over 3, and then you have 2 counts, and then a space, and then n. We still end up with fewer characters if we just inlined it. And then this now can be t to the 4, because of how we actually ended up doing that. We actually saved more space by choosing numbers carefully. Okay. Try again. That gets us at 361. Still fails because we don't have any output. How do we not have any output? We have a print here. Oh, you know what I think this is? They probably took the all 1,000 characters of pi, slapped a print on it. I almost want to give that a shot. But we're also at 360 characters, so if we manage to get this working and manage to print it out, then it should work, right? Oh. Yeah, no, this doesn't actually... Wait a minute, hold on. So the reason this doesn't work is because we actually still end up at 0 length, since we never fill the first slot, so I think we actually do have to do it this way. Unfortunately. MP Sonic All-Stars Racing, welcome in. It's kind of Code Golf. It is actually Code Golf. If you want to give it a shot, you have the link is pinned to the specific challenge we're doing. Earlier we were doing JavaScript, we got 162 characters. The top answer is 16. I have no idea how they did that. Right now we're trying Lua. We'll probably try a couple of other languages afterwards. I prefer the kind where it takes less cycles. 60, not 16. 60. I don't think I've tried the one where it takes less time or cycles. I've only ever done the character count one, but that could be interesting too. Yeah, so the answers here, we have a big jump from 930 to 1009, and I'm assuming because you have to print the first 1,000 decimal digits of pi. I'm assuming all they did there was print and then the string containing the all those characters. No, we're still not getting any output. Hold on, did I even change this? I did not change it. And then we have one more here. And we have to do it this way. And we can't put that in any other variables because it needs to reevaluate every time. But the answers aren't actually calculating pi. Well, the ones that are low probably are in some form or another. And they're not using any sort of compression, because otherwise you'd see the bytes and the characters probably being different numbers. But also I tried running the bytes or the numbers of pi through a compressor. It didn't work out. It would be more than what you would expect for this. So they're actually doing some sort of code that's presumably calculates pi in some form. They could be doing pattern analysis, but then you're getting into compression. And unless you're doing something smart with the compression. Okay, so now we're getting somewhere. Because I think this should end at... no, I think we need a couple more digits. We need a couple more digits. maybe we do need an N. Because we had 1,000. So this was originally 10 times 1,000. And then this was 1,000. So this is now going to be 1,000 plus 3. And this is going to be 1,003. Which then we can reduce, so this is going to be 10 times 10, 10 to the 3. We can make this 30. So this is going to be t to the 4 plus 30 divided by 3, and we can reduce this down to 10. Wait a minute. Divided by 3 plus 10. We get rid of all that. Is that right? Did we actually save any characters here? I think we did. We must have. Versus what we had earlier. With the parentheses. Because it would have been an extra set of parentheses here, and then you divide it by 3. So anyway, we saved 2 characters by bringing this one out. It was the same trick that we did with the JavaScript. And then we have 1,003 here, which I think is probably because we can't do t power 3 plus 3. That's more characters. If we do, no, I think this one has to stay 1,003, because unless we can divide that by something, Wolfram Alpha, factor 1,003. 1,003. 17 times 59. That's 5 numbers. Or 5 characters. That actually doesn't save us anything. So I think this one stays as is. And then the T's we still save because we have a bunch of 10s. That should be okay. Can't believe this guy can't factor 1,003 in his head. There's a lot of things I can't do in my head. Pull out a calculator for a lot of basic arithmetic. I don't know, I'm too prone to off by 1 errors. The downside of being a programmer. Okay, hold on, what are we looking at? We're looking at a way to get... We have 0, 3, and then the rest of the stuff that we need. So we need to chop out the first 2. And then insert a dot. Can we do remove? With table data position, remove an element from the table in a specified position and shifts the subsequent elements down to fill the gap. But I want a range. Can we get a range? Table.pack. No, we can't do that. I realize you probably can't see what I'm reading here. It's pretty interesting. Yeah, I like Code Golf because it throws away all of the best practices that you typically want for production level codes, and trades it for a different type of optimization. And it means that to be able to optimize properly, you need to know the language very intimately. In particular, the grammar and all that. So even if it might not be useful necessarily for writing production code, it means you understand the language better. And it's fun. This is the kind of optimization hackers use when hiding Bitcoin mining functions in their website. Well, for those ones you have minifiers for, which can do all this kind of stuff for you, or in a way anyway. But yeah, well, this is the kind of stuff that sometimes you would have to do for back when space was limited. Now, I've never programmed in an environment where, I mean, apart from Code Golf, where the number of bytes in my program had were restricted. But say old games would have been like that, probably. I like Replicude's approach of counting tokens rather than bytes. Okay. Yeah, because that's yeah. Is your score based on the number of tokens then? The most the smallest shader you can, because I would have expected it to be more based on runtime. So the way I say it, the runtime is probably more important than the size of your program, but I don't know what the goals of the game necessarily are for counting tokens. Wonder if minifying your code here would help in JS. Maybe. I think the JS one is already smaller. I don't actually know how the code works, to be honest. We're just taking this. This uses a slightly different algorithm. I think it's still the spigot algorithm, but it's a different set of lines than what the JavaScript one is doing. So what might help here might not help in the other one. There are two score metrics, tokens and operations. Okay. Yeah, that makes sense. You can optimize for one and then probably offset the other. Or sometimes, yeah, and optimizing one, you end up optimizing both. But not always. So anyway, we're looking for a substring of some sort. Sort would work. I don't think we want unpack. Because I don't think Lua has a concept of rest variables. Modding product technically counts as having a little bit of limited space programming. Yeah, because you're injecting things into memory or something, right? Lua table. So one, we could just remove the first two elements by hand. But that would mean running table.remove twice. I don't want to do that. Yeah, patching machine code into the middle of existing functions, which means that you're very sensitive to if I'm not mistaken, it has to be pretty much exactly the same width or same size to make sure all your offsets are still the same. Print results. Oh, some. Okay. Lua table subsets. Or slice. Unpack. Okay, I didn't expect that. That could actually... Table indexes will be started from one, not from index, which we don't actually care about. That's fine. Do we have to unpack, pack, and then concat? It's going to take a lot of characters. Do we need end? Is end if omitted unpacks all elements from the start of the table? Okay. So what we can do then, actually we can replace. Where is the replace? Well, we can do O at hold on. O at 1 equals 3. And O at 2 equals dot. And then we can table out concat this. This is going to be shorter than whatever else was there. I might need this. $386, which puts us up here, around here, which is pretty high. I would 386. Yeah, just after 10th place. Not bad. Assuming it works, which it doesn't work. Okay, we have some wrong numbers. Does this algorithm even work? 3.1419265. Where did the 5 go? Did we miss something? And we're missing a whole ton of numbers too. How many iterations do we need to get 1,000? Okay. All right. Fine. N equals 1,000, 2,000, and we'll just start iterating this and see what we get. T times n. Oh no. All right. Well, we're gonna get this to work first, and then 10 times n divided by 3. Where do we get the plus 10 from? Oh yeah, I mean, I guess we did expand this one. So 10 times n divided by 3. If we make this 2,000, and then we make this one n. At least everything else is correct. Just needs to make sure that we have the right precision. Neko, welcome in. I don't know if you've done code golf before, but it's certainly a challenge. Yeah, that's too much. That's also not the right numbers. Why are we dropping numbers here? If any of you want to try this out, the link to this challenge is pinned in chat. You may still have time before the challenge, oh no, actually it's probably done right now. No. You may still have a bit of time before the badge runs out. But it might just be 10 minutes. Anyway, every instruction I overwrite needs to be included in the patching machine code in the middle of existing function. Some of the time I want to overwrite separate instructions, but other times I want to clobber as little of the original as possible. Every instruction I overwrite needs to be included in the replacements. Any operation I'm trying to do, keep as is becomes an undesired tag along. If an instruction has a memory address in it, I can't copy it over because it's represented as relative to the instruction pointer. So when I managed to reduce my hook from 12 bytes to 5 was a major boon, as I believe I mentioned before. That sounds pretty tough. Okay, but we took this algorithm from here, so unless we've translated this improperly, are you saying this doesn't work? Because it very well could be the case that this doesn't work. Alright, let's put this in the lower REPL. We need up until 1989. So this actually needs to be 1001. 1002. A 1003. 98938. 1415. Okay, so the original does print the proper digits. So I think we messed up in our. Actually, we can just concat that away, I think. Yeah, alright, so I think we have to do 102. 102 and then just chop off the last one. And we're assuming this is correct. Okay, so we did something wrong in our translation here. Instruction with a memory address includes basically all jumps and branches too, which is proven quite annoying. And so it sounds. Okay. So we take the original and see where we went wrong. So we have for j equals 1 to length. Length is this. A equals j, then 2, 9s equals 0, predigits equals 0. For j equal set scroll bind and set scroll bind as well, so we can both scroll them at the same time. Mod F and F mod. Oh, okay, so I messed that up. This should be G. That should be F. Oh, no, this is correct. Mod F is mod F here, and then F mod is that there. So then we're just checking to see if they're all the same. So T is 10, N divided by 3, J equals 1, length, A at J is 2, 9, so N, P, 0, 0. For J is equal to 1 to N, Q equals 0. For I equals length, 2, 1, subtracting 1 every time. Then we got X equals 10 times A at I plus Q times I. A at I is equal to math.f mod, which is G. X times 2I minus 1. Then Q. Yeah, we put this all in one line because you don't need the. If you have a parenthesis, you don't need a space afterwards. It'll just count as a separate token. So Q equals math.mod F. So we put that on F, right? Yeah. X divided by 2 times I minus 1. I don't think we can. Actually, hold on. We might be able to pull that out. We'll make sure this thing works first. A equals 1, math F mod, which is G, Q, T, and Q equals F, so mod F, Q, divided by 10. If Q equals 9, then 9s plus 9, 9s equals 9s plus 1. Else, if Q equals 10, then you write the predigit plus 1. So in this case, our writing is adding to the array, or sorry, to the table, or appending to the table. And then 4, we can move this to its own line because it doesn't matter. For k equals 1 to 9s, do write the 0. And so we do io.write stats, and then we end, predigit equals 0, 9s equals 0, and we get that there. Else, write the predigits, p equals q. If 9 is not equal to 0, then for every k equals 1 to n, do add 9, or write the 9, then 9's equals 0, then 4 n's. And we do this, then how... This is the same code, is it not? Okay. Does this actually work? Does the base code work? Yes. Yes, it does. Okay. We need closer inspection here, because this is... Because we checked the code, didn't we? It should... Hold on. 1000, 1003... We can make it 1000 and then just tack on whatever's missing explicitly. That might be shorter. Now I'm missing one. So O at so every time we access aha. Okay, here's our bug. It's this, we're missing the +1 there. Because every append to O actually has to have a +1, and we missed that from last time. Okay, so this should work. But we have too many because we had said 2000. Okay, so if we did 1000. If we do 1000, we can actually remove... Yeah, if we do 1000, then we can make this t at t to the 3, which we said t to the 3 actually is shorted by doing this. And then this would be t to the 3 as well, which means this is t to the 4. And that gets rid of that. And then now we need to add another one. So we're one digit short. I think we ended up to 98 or 19. I don't remember. We make this just 1000. Then we end up at 98. We actually need 989, so we can just add another 9 to it. Can I get away with this? Does Lua have string coercion? Does this print 99? No. No, it doesn't. Okay. Alright. Alright. I don't know if that's worse or better than JavaScript. But that doesn't mean that we need to put quotes there. Okay, so that gets us to 388 characters, which is still within the top 20. Still fails. Because how do we end up with 12 point something? What? 10 times 10 times 10 is 1,000, right? Am I running into precedence issues here? Is this the problem? Thankfully not. Okay, hold on. So we have 1,000, right? I realize, no, hold on. Yeah, I can actually just run all this stuff manually here. io.write. Why? It was working before, to an extent. So 10 times 1,000. And 1,000 here. Or string 2 plus string 3 in Lua gives the number 5. I think you probably need a concatenation. Oh, yes, you're right. You're right, because Lua has different operators for concatenation and addition, like PHP does. Okay. This is node. So if we have 3.14 dot 9. That's a dot? Oh, sorry, dot. Right. I don't know if that saves anything though. Yes, it does. Yes, it does. Yes, it does. Okay. Because that saves one character. Yeah, sorry. The dot as concatenation is PHP. Okay, what happens if we concatenate a table? Probably get a type error. Yeah, that's what I'd expect. What do we do? Why is this giving us 12 now? It used to give us 3 point whatever. A wrong 3 point whatever, but it was still 3 point whatever. Where'd the 12 come from? Now back before we did that, wait a minute, hold on. That means this isn't working. That means this isn't working because it's not overwriting. It's not overwriting the first and second entries. What? Hello? But it was working earlier. It was working until we removed this. Or until we added the +1 here. Well, I mean, not now, I guess. This is where I should probably put things in version control. I have undo history. Hold on, I have undo history. Okay, now we're getting somewhere. because this at least gets us some point of comparison. You know, remove scroll bind here. Diff this and diff this. See where our differences are. That doesn't actually matter. This one does matter. That one is the same thing. So the only things that we've changed are things that actually does this not work? Do we need to put this in parentheses? Possibly. Okay. We'll give that a shot. See if that changes anything. So we know this doesn't have to be in parentheses, but this might. No, it's still 12. So N, where is N? N is used in those. Those are the wrong delimiters for this one. Just those three places, which we've already changed. It's 10 times n. N is 1000 in this case, so if n is 10 to the 3 times another 10, that's going to be 10 to the 4, so this is correct. Or should be correct anyway. Okay, so what if we do 10 times 1000? And we have 1000. I think we tried this already. It's still 12. What's changed? Other than not having n. Right, this is 3. Okay, so we can start with this. We can start with code that we know more or less works. And then we can change things. So we know this has to be +1. And we know this is more of 1000. And we know this is not going to work properly because we're missing a number. We're missing 2 numbers. So we can then add. We can add .89 to the end here. That's 393 characters. So this should work. And now we can reduce this because now that we have n here. We can have this be t to the 4. And then this can be t to the... Okay, so that is the exponent. Then t to the 3. Then we can remove n, which we already have. And then this should just work, right? What changed? What's the difference between this code and that code? Is it this? Is this the problem? Can't be. Okay, whatever. Well, we can give that a shot. If it works, then I guess. Where is this? If Q is equal to T, then this... Because this should not make a difference. Should not make a difference. Yeah, it still works. Okay. And then, does it still work if we remove more spaces? Like, for example, between numbers. Apparently not. For I equals 1, 2, 3, do io.write I end. Does this work? Malformed number near 3 do. Okay. We can't do that. Are there any other places where we can shave off a few characters? I don't think we can reduce this one, can we? P equals Q. We need the old value of P before we assign Q to P. So I don't think we can reduce this further. If n is not equal to 0, then we do that. N is always going to be greater than 0, right? Is n ever going to be negative? N is 0. N equals n plus 1. So if n is greater than 0, we can reduce that to a greater than sign. Let's shave off 1. Do we have any more knots anywhere? Just the 1. So that should shave off 1 still. And then let's get rid of the diff here because we don't need that anymore. Can we reduce any of the math here? So we have 2 times I minus 1. If we make that, say, x equals 2 times I minus 1, we can make that into x, and we can divide by x. We can save a bunch of characters that way. I don't think we're using x anywhere else, so that should be safe. We have t there, we have t, p plus 1 equals 0. I think that's the only obvious one that we can get, because that one's repeated. Anything else is not repeated. Getting a bunch of zeros, but that's fine. A at I, Q times I. Okay, we'll give that one a shot. All right, save 2 bytes. We're now at 385. We're still at 12th place. Somehow they managed to get it up to 356. I don't know how yet. Can we do table lock and cats? Lua object oriented. Colons. Because this should... I know Lua has a thing for this, right? Just don't know how exactly it works. And sometimes it works and sometimes it doesn't. And the method call is this. The effect of the colon is to add an extra hidden parameter in a method definition to add an extra argument in the method call. To do that. You can find a function with the dot syntax and call it with the colon syntax or vice versa. Right. So presumably that means we should be able to do table.concat this. Right. Attempt to call a nil value of method concat. Foo bar is sugar for foo bar. Foo. Yeah. Oh, foo. Oh, I see. That's why you can't do that. Right, because it would be. Yeah, because that's not self. That makes sense. So is there a way... is there a way to compress this? I don't think there is that in that case. Man, that's unfortunate. Is there a way to compress this? Not unless we unpack. Can print take multiple arguments? I don't think it can. Or print, hold on. Print is one of the things that come from here. So we can give this a try. We do 3 points. And table dot unpack from 3 and then 89. And then put that into its own table. Or not its own table. This one's worth a shot. I don't think it can. Yeah, okay. Can't do that. I also don't expect this to work because it's only going to take probably, yeah, just the first or whatever argument that is. That's probably not going to work because you can't concatenate tables like that. No, I don't see a way to compress this. I think we're kind of just stuck with that. Probably, unless there's a way we can compress these two. So at element 0 we have a 0. At element 1 we have a 3. Sorry. At element 1 we have a 0, and element 2 we have a 3. We want it to be 3 dot instead of 0 3. That's why we're doing this. And then we're adding on the 8 9 afterwards. Because we don't have enough. I don't think we can compress white space anywhere because new lines and spaces are equivalent. And I'm not seeing any oh, hold on, wait a minute. No, we have no single. So in Lua you can have, if you only have a single argument to a function, you don't need the braces. Which means we can get rid of this. I guess not. Or was it only if no, it's if you have a single argument and that argument is either a string or a table, you don't need the braces. Anything else you do need the braces. I don't think we have that anywhere else in our code. This is a number. Okay. Well, I think that might be as best as we can get for this one. Do I want to attempt another one? What other languages can I golf? What other languages am I competent enough to golf in, rather? That would be kind of funny. 667, I think, maybe not. How do you golf in tech? And then everyone else just... Okay. Yeah, everyone else just gets over 1,000. I think it's only true if the argument is a string or table literal, yeah. I know PHP. I don't think we're gonna be able to... Oh. Okay, so people have mismatched bytes and characters, which means they're all using Unicode. Which means some sort of compression shenanigans are happening, and I don't want to deal with that. Bash at 103, but also numbers. The Bash solution here isn't particularly pretty. Translation of algol 68. They actually did add algol 68 to the list of languages. I don't know how to write it. Algol 68 predates C. Is actually, if you trace the line back, if you trace the parentage of C, you get algol in there somewhere. So presumably, I should at least be able to understand algol, but I don't know how to write it. But yeah, Bash, I do not want to deal with this. This looks like it's the same as the Lua code, or rather the algorithm in Lua. Wait, if it's the same algorithm as in Lua... Perhaps it wouldn't be too bad. Declare A, so that can be okay, I can see how we can maybe shorten this. Alright. The stream is going to be longer than 3 hours and 14 minutes, but I think that's okay. We can say that we did 3 languages, and that's a close enough approximation. Okay, and we're gonna get rid of all the get rid of all the comments. So GenPy digits, is this a thing that's actually used for anything? No. Print digits. Print digit is this. Yield. Okay. We have ways to bring that down. So we have echo or prints F. So this is just standard out, so that's fine. Base 10, we can hard code. So 9 is equal to 9. We can just do that. Why don't you just replace that with a literal 9? Oh yeah, because it's any arbitrary base. We don't care about that. We're just working with base 10, so we can actually get rid of this. And then we can Ah, I see. So I think this then is this any arbitrary base? Does that mean we can actually reduce this down to this? Except this uses big ints, and Lua doesn't have big ints. This only works because it's a big int. Okay. Well, I don't think we can do that. So, this then is ++ because we can do that in Bash. That's fine. If digit is equal to 10, out is equal to pre-digit +1, yields out pre-digits. So anything with yield we can do, we can do printf. I wonder if we can shorten that. We have 3 calls to printf. And we replace 9s with n. Yes, 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 and yes. We don't care about local. This can all be in the global space. That's fine. Base places. So this is the 1000 times 3. And then test decimal places. We don't actually care about that. And the new line, which I don't think we care about, because any trailing white space gets stripped, so we don't care about the trailing new line. And we don't care about print digit anymore. We don't actually care about this. So do we have n anywhere? Because we can change that to n. N is equal to 1000, so 1000. That's going to be, base is equal to 10. No, base places is 1000. Base place, s base places. Not that one. That one. If you do control R, control W, when you're in the Vim command line, it inserts the current word under the cursor. Pretty handy. So this can be n, which can be 1000 because it's only the 2 places there, plus this one. Which means actually it is worth doing that. N times 10 divided by 3. Can that be reduced further? If I make this 10, does 10 appear in a bunch of places? I don't think it does. Not like the other one. 1, 2, 3. In a couple places here. So digits, this can be shortened to d equals that, because all this does is declare it as an array, so we can just make it an empty array instead. We don't need yields, because we replace that with printf. N is equal to 0, pre-digit is equal to 0. We can replace pre-digits with p, capital P. And I forgot actually that, where did I do the N? Oh no, this is fine. because these are all in arithmetic context, so you can have variables without the $sign in here. UPB digits. I don't know what that means. I think it's the length. So UPB digits, we're going to replace that with L, because that's what we had in the other one. I'm going to call that U, because I actually don't know what this... I don't know what LWB digits means. And then LWB digits is going to be L, because that's what it starts with. And then we can compress the white space. Okay, so we don't need this, don't need this, don't need this, don't need that, don't need this, don't need that. And we do need the space here. Digits. Where do we get digits from? Did I accidentally delete something I shouldn't have? Right. I replaced it with D. Digits with D and GC. Then place. Or we can replace that with P. Yes, 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 yes. Place is not equal to 1. And if place is not equal to 1, that actually sounds like we can probably reduce it to something else. Because if P never ends up being negative, which it probably isn't, right? If P never ends up being negative, then this can be greater than. And replace all of these with set a shift width equals 0. We don't want automatic indentation. Semicolons and new lines are more or less equivalent, so we can actually replace the semicolons with new lines and make things a little bit more readable. Just a little bit. Then we have this, then we have this. If digit is 9, then this, else. Can I do this? I think I can do that. Yeah, I should be able to do that. Because it should start a new token, and it should know to start a new token. Else, if, then this prints F out, P equals 0. Where is this if going to? Where's the FI? Out here. No, but this one goes here, so that's that FI. Then we have the else. What happens when I remove the indentation a little bit too early? Oh, that's useless. Okay, so we're gonna let it figure that out first. I need to see where this is. Can we remove this? If fi, if else fi. N equals 0. Only in the case of this. Because I was thinking, can we reduce this to do an elif? Is that worth it? Possibly. We reduce this elif that, and then we need to put this in here. And then else And then we can get rid of that, and I think that saves us 1 line. Because that gives us... Yeah, I think that saves us... Oh, it saves us 1 line, but I don't know if that saves us characters. Because then we save 2 characters from here. But you still need a space here. Actually, it saves us 3 characters because you still need the space. And it saves us another 3 characters here. So that's 6 characters. And then you have 1 set and another set. I think it actually does save us characters. So we can make this elif. And then flatten things out. Put that there, put that there. So yeah, I think that saves us a couple of characters. Or do that, print F done. And because this has to be pure bash, we can't use sequence or anything like that, unfortunately. I think we need to preserve... Oh no, we don't have R. So we can actually change repeats to R. Because we don't use R anywhere else, so that's fine. Print F9. 9 is a literal 9, so that's fine. I think understanding what this algorithm actually does might be able to let us compress it a little bit more, but that would require reading the code. And prints FP. The last one. Pi.sh, because I need to see what it would give us here. Base is referenced but not assigned. Because this is now 10. This is also 10. Uh, 10 replaced with B. Now if we have more than 3, I think this actually saves us some characters. No, no, yes, 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 yes. We do actually have 10 in a bunch of places. Digit equals that. And I need a bash shell here, so we can either do if so A equals 9, if A equals 9, we get equal A. I think I need a bit of test. A equals 8, and then I think that actually changes 8 or A. But we can do A is equal to 9 this way. No, we can't do that either. Because that's not how that works. You need spaces, and that's going to take up a lot more. You can do it this way. Save on the spaces, but also this isn't going to work either. So I think the arithmetic context is probably going to be the most compact way to do this. Unfortunately, we're stuck with the double equals, so. Alright, so we have this, and then digit. Can we use capital D? We can use capital D for digits. Yes, 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 yes. And do this. Why are you complaining about it's mismatched? Mismatch parentheses. Shouldn't be. Bash, I think, is probably smart enough to deal with this, because it would normally be that. Because you have a parenthesis here, and then you have the double parenthesis to close off the arithmetic context, but that should hopefully be fine. Hopefully. And then we have this. We have the 2 times I minus 1, which we can, as before, reduce down to x equals 2 times I minus 1. And I think this still saves the characters, because it would mean getting rid of this, and also getting rid of this here. And that is a bunch of characters saved, because we're cutting this down basically in half. So that's fine. Can we use out anywhere else? Can we just... P plus 1? And then not deal with that? Then print f p plus 1, p equals 0. For n, do this, do print f0, done. P is not equal to 1. P, where does P come from? P is length, is less than or equal to u. Whatever u is. U is this. Is L. L is equal to 1. If L is not equal to 1, then you print... If L is not the first one, then you print it, otherwise... Okay, so this can be greater than 1. Because our starting point is 1, so everything else... and then we're adding to it, so everything else is going to be greater than 1. So that's fine. Why can we not start some of these at 0? These will all initialize to 0 if we don't start them. So, for example, if we have print n, that should give us, or print fn, that should give us 0. N equals n plus 1. Or let's go with j. So this should give us 1, because they all initialize to 0. So we can actually get rid of n and p, because they implicitly initialize to 0, and get initialized to 0 on first use. And then we still need this d equals 0, because otherwise... because we do need to reset it every time the loop happens. And it's going to be shorter than any other initialization code that we might have. Unless we put this in a subshell, but then that ruins... But we need these... I think these variables need to survive outside the subshell, or outside the iteration, so I don't think we can do that. Because if we put the for body into a subshell, so d equals 0 is the digit here, and then things that the things that need to survive outside the subshell is lowercase d, which I think we actually do print, or we do assign to, so that needs to stay, which means we can't put this in a subshell. because anything that's inside, any changes that are made inside the subshell to the environment, don't get propagated outside the subshell. So it's basically a self-contained area where you can do stuff with. So if you're ever doing a CD into a place and you want to back out, a subshell is temporarily CD into some place and then do stuff, and then you want to CD back out. The subshell is handy for that because the working directory also does not get affected if you change it inside the subshell. You're still in the same working directory outside the subshell. So it's useful for sandboxing in some sorts, but it's not going to be useful here because we need the variables to survive outside. Is it going to... Hold on. If we do... Can we do capital P? Can we do... print F. Now we do a subshell like this. That'll actually give us a way to do that. Does this save us any characters? So if we have 1, 2, 3, 4. I can't count. Okay, that's 4, and then 5. 6, 5, and then 6 for every identification, and printf is already... So if we do printf a bunch of times, this will actually save us stuff. So go with O there, go O here, and I think this does save us characters. I'll do another one there. O0. O9. And then P, double quote print, I don't care. Dollars unnecessary on arithmetic variables, so we can actually get rid of this. So that was the kind of message I was hoping for. This is fine because we are very much in control of what we're doing here. This might be okay. Get rid of white space here, we can get rid of the white space there. And I think apart from the ifs, so the ifs we can remove the white space from, probably, hopefully, we'll find out. Then we just gotta get rid of the indents. Okay, I think this might be good enough for a solution, and we can give this a shot. Hello. $393 characters, which puts us 6th place if we get this right. I don't think we get this right because we haven't added a 3 dot anywhere. But we'll see if it runs anything. Oh, it times out because it's too slow. It gets to whatever this amount is, and then it times out. Does this mean we actually have to read the code and figure out what's going on here? How to optimize this? Man. So I'm not seeing any obvious optimizations here at the moment. One, because I don't exactly know what this code is doing. It's doing a bunch of math. Clearly, it's possible to do because people have been getting less than 1,000. So the trivial answer is this, 109. How do you get 100? Wait. Echo. The trivial answer is 1,007 characters. You just slap on echo in front of the number. But that's boring. Why would you do that? So if this is too slow, how can we speed it up? We have the Lewis solution, which is basically the same thing, it's just working backwards. I wonder if that matters, actually, if it's faster to work backwards than forwards. I'm seeing a bunch of the same things here, or some similar constructions. I just don't know what they do. I don't know if I want to figure it out. Right, because that's do 0, 9, so output 9 there. For k is 1 equals n, so how does this get calculated? So if the length, if u, whatever u is our length here, so this is n times b divided by 3. Wait, does bash have exponent? Bash exponents. Double dot, or double star, which is not going to help. You're better off at 1,000 here. So u is the same thing as this. So for j equals 1 to l, do a j, so whatever a is, Lua, whatever a is. Const n is equal to 1,000, length is 10 times n divided by 3 var jk 9's predigit integer, a is an array of 0 to length of long int. Where do you get the 2's from? Start with 2's, start with a bunch of 2's. For j is 1 to n, where's the part where you go work backwards? Why would you work backwards? So if I is greater than length, only calculate as far as needed, plus 16 for security digits, about 5 decimals. I is I times 10 divided by 3 plus 16. So that's what we have as u in our oh, actually no, it's this. If I is greater than length, then I is equal to length. Result is 0. And then working backwards, you have x is equal, where do we get x? X is just an integer. X is equal to 10 times a at I plus the result times I. Result is x divided by this. A is always x minus result times this. So that's x mod that. So we have that in here. That's this one. That's this one here. So why work backwards? Does it even matter? I don't think so. Results is x div. Or you're working backwards. But it doesn't reference any older ones, I think. Because x gets reset. I is whatever the loop counter is. The result is set to. Oh no, this does. Okay, hold on. This does rely on the previous results, and then why does this one work? If this is working forwards. Oh no, this is still working backwards. So you still work backwards. U to length. Work backwards. So then the question is, where is it taking up all its time? Why is it taking 5 seconds to run this entire thing? It might be the printing. I wouldn't be surprised if it was the printing, because printing actually does take a long time. So if we don't do print f equals, if we instead do O is equal to an empty string, O plus equals this, because that should concatenate as a string, right? And then we have echo O and then the P. So then we can get rid of this. So it's entirely possible this is fast. 2, 3, 4, 5 would have gotten killed here. Okay, so printing is not the bottleneck. So then the question is, what is the bottleneck? Probably this, isn't it? What is N? N starts at 0, goes up until it does a whole bunch of stuff. I'm gonna add a time there. Okay, so we need to add an outer loop. So whatever this is, that's too far. And okay, hold on. So we got here. That took next to no time. Then we got here. Is there a repeat? If all this does is repeat this a bunch of times, is there a function? Is there a bash string function that lets us repeat strings? How large can n be? That is a very good question. What do we do with n? Because if all this is just a string, then we can actually just multiply by 10 to the n. Wait a minute. No, we can't do that. N equals 0, r to the n equals 0. So this is relatively small. So we can math this. I think we can math this. So what's the formula that we need to repeat a number n times? Formula to repeat a digit n times. Function to repeat number n times. 10 to the n minus 1 divided by 9 times x. Sounds about right. I just don't know how large n is and whether it's As long as it's below 63, then we should be okay, but I think it might go over 63. Ten to the n minus 1. So, if we do echo 10 to the 63 minus 1 divided by 9, we should get 63 ones from this. And we don't, because it too many oh, we don't even get it for that. Okay. So this is non-viable, unfortunately. 16 is too much. 17 is that too much? 19 is too much. 18 is our limit, and we're gonna get more ends than that, so that's unfortunately not viable unless we do some extra math. But at that point, actually maybe the extra math is worth it, because if we're stuck for runtime, then runtime at this point is more important than characters. Can we do some dynamic programming where if it's a certain n, then we only calculate it once? Mr. E, welcome in. Are we winning? I don't know about that one. Well, we haven't won the previous ones that we did. So the JavaScript one, 162. We're here, 144th. The top answer is... Oh, no, I don't want to do that. The top answer is at 60 characters, and I have no idea how they did that. Lua, we had 385. That puts us at 12th. Which is pretty good, I'd say. Although it's still over double the top answer. But at least we attempted it. Unlike some of the other ones here who are over 1,000, basically just put the number in quotes and printed it out. So that's good. And then now we're trying Bash, and it's proving to be difficult. Because we are running into runtime timeouts. We need to optimize the code here somewhere, which means understanding how the code works, understanding how the math works, and seeing if we can get around that. Because we can... Okay, hold on. So, I don't know how... The problem here is I don't know how large n gets. So we get an n++ over here, and that's the only place we're getting n++. If d equals 9, then n++. What language are we currently on? We're currently on Bash. So shell scripts. Actually, hold on. D is a small number. If D is 9, then we n++, which means only about a ninth of the time should we get this number. So this is actually pretty small, relatively speaking. But a ninth of 1,000 is still 100 loops. So if it's about 100 loops, then we can actually only loop 10 times. If we divide by 10. No, this could work. Okay, hold on. Because we know the formula. And we know the formula, and we can get... Oh. Actually, this is even better, because what we can do, we can print F. We can get print F to do this for us. 0... Let's say, I don't know, what can this be? 100? 0, 100D? 0? That prints 100 zeros. We can get printf to do this for us. Printf 0 n. I think I actually do need the things over here, unfortunately. What are the rules for this? So for Bash specifically, it has to be pure Bash, so you can't call out to any executables. But the overall rules here, you have a problem. In our case, we want to print the first 1,000 decimal digits of pi, and it has to run in under 5.5 seconds or something like that. 5-second timeouts. And you want to try to get as few characters as possible, or as few bytes as possible, in case that distinction matters. If any of you want to try this out, the link is pinned for the challenge. And you don't have to know how to calculate pi, because they do give a link to the Rosetta code, which has some sample code that you can base your stuff on, which is what we're doing. Because printing 1,000 digits of pi in a language that uses limited number formats, or rather number types, is means it's not trivial. Okay, so this we can actually make that, which means we can get rid of this loop. Very good. And then we can do the same thing here. But instead of a 0, we can make this a 9. Where else do we do the O+? E + 1. Okay, so that's probably good. I'd probably only be able to put it in quotes and print it out. I mean, that's a start, right? But there are other challenges on the site. Couldn't find FI for this if. Did I accidentally delete one? Because I still had the do from the 4 that we removed. So we can get rid of that. I don't care about double quotes, that's fine. But yeah, the site has a whole ton of other challenges too. I don't remember if you were here the last time we did this, back in 2024. Apparently it was that long ago. But we did do a bunch of the other challenges back then. So this should run significantly faster, because we're getting printf to print out all those 1s and 0s and 9s. So probably not that much faster, because I don't think that's our bottleneck here. Okay, so if we change this back, instead of going to instead of doing this, make O a function that calls printf. So we had this earlier. O is this printf, and we want to use we only use printf so that it won't print a new line. Echo will print a new line unless you have -n, but echo -n is longer than printf. I think. Yeah, it's longer by a bit. So we want to use printf for that. Which means we can change this to an O and save more stuff too. Which means we can change that to an @ so we can actually expand out properly. Yeah, that should work. Hopefully. We'll find out. I don't think this... So I think the bottleneck is still in the calculations. So this might not actually help all that much, but it's worth a shot. Yeah, we're still timing out. Also, this is wrong. We should not be having all these 9s here. That's not right. I messed up. I removed one too many things. I think did I leave out an else? I think I left off an else somewhere. If digit is equal to base, then out pre-digit yield out 0 repeats 0, 9 yields 0. If place is not equal to 1, then yield a pre-digit, and the pre-digit equal to digit. It's this one. 4 repeats I equals 1, repeats 0s are less than 9, do yield 9 done, so print out all the 9s. Oh, this doesn't actually work. This doesn't work for the 9s. However, we don't actually get a whole string of 9s anyway. We don't get... So we don't get a large string of 9s in Pi until much later. So I think it might actually be safe to do the whole this bit. And then since we multiply by now, we actually don't need that anymore. Then we can just do this, and this is times 9, or times n rather. 10 to the n minus 1. Yes. So that one we got from some Stack Overflow answer. Or maybe a Math Overflow? Somewhere in here, yeah. Mathematics Stack Exchange, that's what it was. So 10 to the n minus 1 should give us a bunch of 9s. Okay. And then this should work for 0. So it prints out a bunch of 0s, and then this one should work for that. That is wrong. We're gonna remove that now. Okay. So now it should work a little bit faster. Maybe. That's not correct. And it's still pretty slow. Where did I first learn Bash? When I was it was through my through using Linux full time as a daily driver. So that was back in high school. My dad had, I may have told the story on stream before, but I'll tell it again. My dad had installed, or my dad had me build a PC because I went through a computer technology course and where we learned about PC parts and whatnot. So I figured that was probably good practice. And so I built a PC using parts that he bought, and then got me to install. Well, actually, it might have been him. It was either me or him who installed Linux on it, because he didn't want to pay for Windows at the time. So he installed Linux, or no, OpenSUSE, and I used that for a couple of years until he got tired and installed Windows anyway. But I'm the type to tinker around with stuff, and so I did a lot of customizations and whatnot to my Linux account, and learn, you know, the tricks of the trade. And if you're using Linux and actually delving into things, you will pick up scripting pretty quickly. So yeah, if you want to learn Bash, full-time Linux is a good way to do it. Something's wrong here, and I don't know what. Oh, because this has to be if n is... Because we don't want this to be if n is 0. Right? Prints f... It's going to print a 0 anyway. We don't want this if n is 0. So if n is greater than 0 and then we do it that way. I'd like to switch to Linux for my next PC. Yeah, I'd encourage it. I think you're probably technical enough to be able to navigate it pretty easily. Oh, actually, we can get rid of a lot of these ifs too by changing them to these types. Yeah. Okay. Let's get this working first, and then we can figure out how to make it work, or we figure out how to pare it down. That's not what we want. Do they make books and manuals for Bash? There are. There is the Bash manual, if you want to read through that. I don't think it's necessarily a good starting point, but it tells you pretty much everything that you need to know because it's the manual. Bash Hackers Wiki, assuming it's still around. Probably this one. There are a couple mirrors because the original died, so this is a good start too. They're probably the two mirrors are probably fairly equivalent. And then there's Greg's wiki as well. So these, I would say, are the good starting points for Bash. I'll put this in chat. About Greg's wiki. And then Bash Hackers wiki. And the second one, yeah, I don't know which one of these are more up to date. And then there's the manual. I'm gonna go ahead and copy that to Twitch as well, and then I'll paste these in Discord later. Or do it now. Yeah, Bash I think is Bash and shell scripting in general I think is useful to learn. Yeah, I'll paste those in the Discord later, but for those of you who aren't in there, we do have a programming channel. We also have a Linux channel, which this would be relevant in. So if you ever want to learn about that kind of stuff or have any questions, that is one of the places to ask. So this is still slow, and this is not working properly. But let's figure out why it's not working properly first. Because I'm pretty sure N was supposed to be... Okay, so we turned this into from a loop to something that always runs, which means that we got rid of the condition where if it's not... if the loop condition doesn't run or is false, then it shouldn't run at all. Which means the 9s. If digit is equal to base, out pre-digit 0, yield out pre-digit 0, do yield 0. You still yield out, so that's that. And the pre-digit is equal to 0 for repeats is equal to 1. Repeats is equal to less than or equal to 9s. Repeats plus plus do yield 0. So if the 9s is less than or equal to 1 is what we want. Or is greater than 1, because we have less than or equal to 1. And so 9's at minimum, I think, would be 1. Is that right? We'll find out. If this runs and this looks the way we expect it to, then it works. And it doesn't. Why? Or I equals 1, I is less than or equal to 9's, I plus plus. So that means if 9's is 0 or less, then you don't run this. Otherwise, if I is greater than 0, then you do run this. Which means I had this right the first time. Right? If n is greater than 0, then you print the thing number of times. And then n is equal to 0. So n is 0 is our base case. If we don't have any 9s to print out, then we don't want... Right? Is this what this is? Okay, we're going to do a bit of debugging here. Prints FA to standard out, or standard error. And if we do run this a bunch of times, we should be seeing a bunch of A's. And I messed up. That is because this needs to have a space. Where are my A's? Why am I not seeing A's? Okay. We're gonna do this instead. dp equals 2p plus o. Wait. Hold on. Let's have n be like 10. also wait. I have this. Hold on. What is this? I forgot to mod this thing. I don't think I've leaked anything. Yeah, there's nothing important here. That's fine. Hi.sh. So we're even running into this yet, I think. Undo. 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 So this is not our issue. I mean, this is partially our issue because this is still... We should still not... this is... In the degenerate case where... Or in the case where n is 0, we still don't want to print anything. I think this is also... This is also probably if n is greater than 0, then we don't want to print anything either. So this is a d times I. Or it's stuck here. So then why is it stuck printing? I mean, this kind of makes sense because we're starting from 1,000 and then going down to whatever L is. L is 1. L is 1. Can I just not just replace that with... Does L get assigned at all? L is always 1. Which means I can just replace that with 1. That doesn't make any sense. Where do you even get L from? LWB digits. Yeah, that doesn't get... That is a constant. 3 characters saved, yeah. Okay, interesting. That still kind of doesn't explain this one. Why... What, 8? Printf 8? Okay, hold on. Can we do any sort of math to get this down? Because if this is new... No, because this is iterative, because it relies on the... It relies on the answers from previous iterations to get this. Which means there has to be a closed form for this, isn't there? But I don't want to deal with that. What is D? D at I. So it all starts at 2. But I don't think this is our bottleneck. This here is our bottleneck. Just going down from 1,000 to 1. Going through this 1,000 times. But this is a non-trivial... This is non-trivial. In here somewhere is where it tells us what this does. Okay, do you think this one is locked? Can't actually implement any of those. I don't think. Billard's formula. This is in base 16. It's not going to help. I feel like unless we have the math for this, we aren't going to be able to figure this out. If D is equal to 9, then N plus plus L. If D is... do we save anything by doing case D in 9... B... I don't think we do. Probably not. Because case D in 9 is already more characters than this. It's the question then is, do we save more from all the then elif then bits? Which, at a glance, it doesn't look like it. But it may be, who knows? But, again, we're still... The problem here is we are too slow. I think we're too slow on this part. So if we do time on this... no, time on this... Oh, you know why? Wait, what's N? N is 1,000. So we're going from 1 to 1,000, and then we're going from U to 1. N times B. Oh, that's why this is so large. Because N times B. This is N. This is B. So that's 10,000 divided by 3. So we're going through this loop 10,000 times. That's why this is taking so long. And it has to be sequential because every iteration depends on the previous results. Okay, so how do you bring that down? Clearly people have done it. Because, I don't know, how do you end up with 103 and be under the time limits? Clearly doable. Somehow, maybe not with this algorithm, but something. This is gonna time out. We only get up to here. Oh. Do we have any other algorithms here? Implementation is limited to 50 digits due to language and memory constraints, but that's fine. Code takes in just under 29 minutes to compute 50. Oh, we don't want that. Bash, does Bash have go-tos? I don't think it does. Yeah, Bash doesn't have go-tos. We can loop and stuff. Go to 300. Go to 300, so if that, then you skip down to here. N times N plus 16. This is the same algorithm. It looks shorter, but it's the same algorithm. So it's not actually going to help us. How do we prevent ourselves from looping 10,000 times? Oh, BC would be nice. I wonder, actually, hold on. Can we save some characters? Because if we can get up to this point... If we can get up to this point, this is... how many characters after the decimal point? We can do a hybrid approach. That's 172? Oh, this is gonna suck. But it's gonna give us less than 1,000, which is something. You know. It would work. It's faster. It's 1,000 and... okay. It's actually shorter to just put the whole answer in. Okay, well, never mind about that. That's unfortunate. So this is the 6 nines. Somebody mentioned compression earlier. Scratch/pi.xc. This is still 500 characters. But also that would mean a decompressing XC, which we don't have. Actually, what kind of things do we have? I don't think we have that many. Yeah, I don't know. I don't know of a way to get this down without, or I don't know how to way of getting this down, getting the runtime of this thing down. Because I can get down codes, but I think we would need the math to. I think we need a closed form for this for it to actually work. DI. Do we need DI anywhere? Do we need this at all? Why are you putting this in an array if you don't use it later? Wait a minute. Okay, so what if we don't put this in an array? Why would you do it this way? Because you can just save the previous variable, right? Hold on. DI is equal to this. D1 is equal to this. D is... what? But you don't reference DI anywhere else. So this is initialization. This is initialization for every for every element in the array. This is doing stuff in the array, but at this point DI is 2 because you never come back to this. The first time you go through, it's a 2, and then you set it to this, which is useless because it never gets... Am I misunderstanding this? Do we actually just set this and not do anything with it? Results. Results is 0. Results I. A at I. A at I. Start with 2s. I mean, clearly this works in some way. LWD digits. I see. So the reason it did it this way is because it assumed an arbitrary base, but we're working strictly in base 10 only, so we have the ability to make simplifications. So this is now 2. We can get rid of this. We can get rid of this loop. And we can get rid of this here. And we can get rid of this. I think. I don't know what this does. But if we aren't using D at all after that, then it makes sense that we just don't use it. Like, we don't need it. Right? If it's not referenced anywhere outside of this, and I here is the same iteration, this starts at 2, then you set it to that, and then we just don't use DI anywhere else, then this should just work. Okay, apparently that did something. And that did something wrong. How does that make a difference? So you initialize everything from 1 until U, so you initialize the entire array to 2. And then, oh, hold on. We may as well read it from this one. So you start the entire thing with 2s, right? And then from the first place until you get to till the end of the places, you start with a 0, and then from you, oh, that's why it actually does need it, because this is an inner loop inside of this, which means this is n squared. This might be n squared. Base places. Base places is 10. That's not n squared. That's fixed. 10 plus 1. This is 11. No, this is 1,000. This is 1001. And then U is something extremely large. Yeah, 10,000 divided by 3 is still 3,000. Or sorry, yeah, 10,000 divided by 3 is 3,300. So we're going through this 3,300 times. And it's a nested loop, so times 10, or times 1,000. So 33. I was gonna say 33,000. It's more than that. That's why we're taking it. That's why it's so slow, because of that. Because of this here. So it's calculating all the digits, putting them in. But then what I don't understand, hold on. It calculates the stuff. Right? It works backwards from the end. And then it does whatever this is, and then so for every place. No, can we? Are we able to? No, but it's iterative. So every place that we go through, it still has to build on what it has previously. So it already is dynamic programming. Because by the time you get, so you calculate the first digit, it goes through all 3,300. And then you go to the second digit, it calculates 3,300 again. So you have a more precise second digit. And then you go to the third digit and the same thing. You get a more precise third digit by doing that. And so by the time you get to the end, you've gone through 33. You've gone through that place 3,300 times, and then times 1,000. Man. Yeah, no, unless there's a closed form for this, I don't think there's a way to. Because we can't. This would have been easy in BC. Or DC. But I don't think that's a thing here. Yeah, I don't see it in here. Would have been easy. BC and DC being command line calculators. Said arbitrary precision. Said doesn't do math though. Yeah, said doesn't really do math, so that's not really an option. I think we might be stuck. I think this might be as good as I can get it, because unless I have a way of not doing n squared loops to do some calculations that build on previous iterations, this here is our bottleneck. And again, clearly possible to do something, because there are people who are getting less than 1,000. But I don't know how that. Oh, actually, hold on. Okay, we can be maybe a bit smart about this. We can try to get something that's less than 1,000. Maybe we can beat the 990. So they got 1,700 by doing this. But you can scan for large, so like these 9s here, for example. You can reduce that to something like this. But I don't think that actually, yeah, that actually increased things. So it would have to be a repeating section in here somewhere. Pi repeating sections, which it's pi, it doesn't, there's nothing there that really repeats in the first 1,000 digits. So you're looking at some sort of compression. But unfortunately, I think the compression here, unless you can get a string of a bunch of numbers here, That's might not work. There's a smarter way of doing this. You take a reference and then you do a 0 or more of the back references, and then you put down a new line. And we'll find out what our longest thing is. Like, we have the 9s here. It's a pretty famous sequence here. What people said is that you memorize up to this point where you have the 6 9s, and then you stop there, and then you make it seem like pi repeats 9s forever. I'm not seeing anything here. We see 989. 989 shows up a couple, maybe not. 950, 971, 939, 3993. I'm not seeing any sequences here that are long enough to put into a variable and then and compress. Six shows up a couple times. Three times, 4 times, 5 times, a bunch of times. That may be a consideration then. Problem is, that's not long enough for it to be worth compressing down, because you actually need 4 characters to insert a variable. If you have a bunch of numbers like this, you need 4 characters. And if you're replacing 2 characters with 4 characters, plus the overhead of introducing the variable, then you actually have not saved anything. Perhaps the way they did this is they made it into chunks, did a bunch of math on it, and then compressed it like that. I don't want to do that. Yeah, I think, I don't know. This might be too difficult. I think we might just put in the trivial solution for Bash and call it that. Kind of sucks, but what can you do? Well, at least we're not the worst. People get 109, which are 1009, which I assume is a Prince F. It matches up. But hey, 11th place by technicality. I guess that works out. I don't know. Maybe I'll think about this, but I don't know of any way to reduce this down unless we have a closed form for this, which I don't think we do. Probably going to be a completely different algorithm. Okay. We're at 4.5 hours. Unless I see a language here that I think I could probably do better, we'll probably call it there. We had 3 languages, which is close enough to pi. JQ, that's kind of... how do you get 150 in JQ? JQ being the jQuery processor, by the way. Schemes is 74. I don't think I know how to do that. Not really seeing anything else in here that I would. I mean, Racket, same thing though. 86. CoffeeScript, in theory, I know how to write. I've written CoffeeScript before. I hate it. Be fun, really. Good luck. Yeah, I think we're probably good to go because does Awk have arbitrary precision? Is this so? Arbitrary, so it has arbitrary precision integers, but with a flag, which means you can't turn it on inside of the script. Which means that is not going to be able to use the same solution as we had for JavaScript. Yeah, that's not going to work. Higher precision GNU awk with big num compiled in. Capital M, that's not going to work. Yeah, I think that might be it. I don't know golf scripts. Golf script doesn't actually, it probably isn't too hard actually, but yeah, okay. We'll call it there. We had a good run with the JavaScript one. We did get, I'd say, an alright score. Certainly higher than a lot of other solutions. I mean, not quite top 50 solutions, but I don't know how they got 60 there. I'm not seeing any. Just doing a quick glance at this, I don't see anything here that we could potentially reduce. So it could be that they're just using a separate algorithm. Lua, 385. Still 12th place, you know, not too bad. Better than the trivial solution at least, and better than some of the other ones that are not the trivial solution. So overall, not too bad. I don't know how they got 120. Probably something similar to some whatever compression they did in JavaScript. And then Bash, well, trivial solution, but seemingly not last place. So I'll take that. All right, today is Saturday. Happy Pi Day, if it's still a Pi Day for you. I'll go reheat some pizza or something, because I apparently do have some of that in my freezer. That brings us to the end of the week. No more streams for the rest of the week. Schedule will be out next week. I gotta figure out what's happening today. Oh, it's already mid-March. Okay. Yeah, I'll figure out what's happening then. Watch out for... There will probably be a music release sometime next week, assuming I get things together, so watch out for that. But yeah, that will be on the schedule. If you're not in the Discord, you can go ahead and join there. We have a channel for programming. We don't have a channel for math, so if you're interested in math stuff, you can just talk about it in general. But you have a thing for programming, and if you're interested in bash scripting, either programming or Linux are the channels to go to for that one. Yeah, if you're interested in trying this challenge out, the link is pinned in both chats. Do give it a shot. even if it is just a trivial solution. But yeah, or some of the other challenges that the site has. There's a lot of them. Some of them more enjoyable than others, but they do continue to add challenges to the site. So there's stuff to keep you coming back. Okay, I think that's it. My voice needs to rest. Twitch. Oh, actually no. Hold on. For anyone who's new here, my name is Penbu, the programming, puzzle gaming, and music making VTuber on Linux. Today we're doing Pi Day Code Golf. Yes. Alright. Yeah, for those of you on Twitch, stick around. We're going to find somebody to raid. And for those on YouTube, if the person I find to raid is dual streaming, then I will also send you there. And also, I shouted them out at the beginning of the stream, but now that more people are here, I will shout them out again. If I can find the tab where I had this in. Aleph Mew is a new math VTuber. Debuted today. I wasn't able to attend the debut stream, but if you like math, then go check him out. There has been a recent wave of math VTubers, so it's good to see. And he is also on YouTube. I'm not sure why he didn't stream the debut stream on YouTube, because there was a scheduled one there, and I know he has streamed before, so it's not a problem of needing to wait for YouTube's 24 hours before you can stream. But I don't know. Maybe his dual streaming wasn't working. Anyway, yeah, I'm gonna go find some raid. Twitch is going to go in ads soon. I might start that early, just so we can get it over with. And with that, we'll call it here. Thanks for sticking around. Happy Pi Day. Good golfing. And yeah. Alright, bye. Forgot to run the ads. I'm gonna run them now, so we get them over with now. Well, anyway, YouTube. Yeah, sorry about not having a canceled stream yesterday, because I just felt a little bit off. Gotta be in good shape to do sound mixing. I wasn't in good shape yesterday. Probably a combination of lack of sleep and then also the weather being kind of weird. It's been I think within a day it jumped from something like 10 degrees Celsius to below freezing, like -3 or -5. It happens once in a while. I think we're gonna get another one of those soon. What else was I? Yeah, 4.5 hours. Well, I mean, so 16:33 was when I started the stream. You might wonder what that has to do with pi, and it's because 1592. So 3 is the March, 14 is the day, 15 is 3 o'clock, and 92 is the minutes. But we don't have 92 seconds, or we don't have 92 minutes in an hour. So that rolls over to an hour and 33 minutes. If I did my math right. So that's now 4:33. Which, welcome back. Yeah, I think YouTube, the person I've found to raid is not streaming on YouTube. So we'll say goodbye to you there. Thanks for coming. And then for those of you on Twitch, we're going to go pay a visit to Saidare. She is doing Hags in STEM, which is her podcast with other STEM creators. This time with fellow V Theorem member Nep. Okay, that situation a little bit complicated. Nep is in V Theorem. Saidare is an V Theorem emeritus. There used to be, but now she's only associated with them. But yeah, same group. If you know Sajiji Altair Z, same group. Yeah. So I couldn't find anyone doing Pi Day stuff and Math Day stuff that I wanted to raid, so we're just going to go into adjacent STEM stuff instead. Nep is a horticulturalist, I think, something like that. She works with plants. And then Saidare is a psychologist. Definitely worth checking both of them out. This is the right message. If you'd like to participate, go ahead, copy that, and paste it in when we get there. And then, yeah, we'll leave it there. Thanks for coming and good night. Bye.